So we know we have a couple different types of problems. Let's start with single value x. When we want to find the probability of a value less than single value x, we want to know the probability of a value more than single value x. We might have a problem where we want to find the probability between two single value x values. And finally, and we could also call this an interval. And then finally, we could have a probability and we want to actually determine the value of x. I call this a reverse problem. So the main thing to understand or be certain about is that to solve these three problems right here, we need the formula z of single value x equals single value x minus the population mean divided by the standard deviation. And so to solve this problem, we need the formula single value x equals the z-score for single value x times the standard deviation of the population plus the mean for the population. Now, this doesn't get us this right here does not give us the answer to these. We still need to take this a step further. Once we get that z-score, we go to the z-score table and get a probability. Here, the beginning of this problem, to begin this problem, we're going to shrink down like Mike TV and start inside the z-table. We're going to find the probability that's given to us and then find a z-score. And with that, we can plug that value into this. We have that, and therefore with those three things, we should be able to determine single value x. So those two formulas are fundamental for solving these types of problems. And of course, we need to get as many reps in as we can until we feel really comfortable with that. Now, let's talk about sample means. So we'll put a little bar there, we'll put a little bar here, we'll put a little bar here. We need to also add the square root of n. And then the procedure is the same. So we'll put in our sample mean in here. We'll put our square root of n here. We'll configure a z-score, compute a z-score, and that'll give us a probability once we go to the z-table. We can also do this. We'll put this here. We'll put this here. We also need to put parentheses and make this a little clearer. Apologize. And we're going to have that. Okay, so these two formulas, and you see how similar they are when we're working with sample means. Of course, we have to remember how we compute a sample mean. We take all the values in the sample that is a sample size of n. So if n is 5, we should have 5 values and take the average. If n is 10, we're going to have 10 values and take the average of those. If n is 20, we're going to take those 20 values and get the average, and so on and so forth. But then once we have that sample average, we have everything we need. And again, here the process is the same. If we're given a probability and we need to determine the sample average, we're going to shrink down like Mike TV, get inside that Z table. We're going to find that corresponding probability that we've been given, or the probability we've been given. And then we're going to find the corresponding Z-score. So in other words, we're going to work our way from the inside of the Z table out. We're going to find that value there, plug that in. We already have n. We should have the standard deviation and the population mean. Once we have those four things, we'll have what the single value x would be for that probability we've been given. So that's how we work with sample averages. And then the third set is how we work with sample proportions. So here we're going to have P, sample proportion. And we have more than a few changes. Okay. So to start out, for the z-score of P, we're going to lead with P. We have P there, we're going to put P there. That's the sample proportion. And then we're going to put in the population proportion. Now the denominator essentially is the standard deviation of P. It is the P-pop, the population proportion, times 1 minus the P-pop, and then that whole thing is over n. Okay, so we need to put n in there, figure out what this is, do that division, and then determine the square root. Once we do all that, we will get a z-score of P, and with that, we'll go to our z-table, and out of that, we'll come up with the probability of that sample proportion occurring given the proportion, the population proportion, and so that'll be that. Now, to do the reverse, so in other words, given a probability, what would the corresponding sample proportion be? Well, we're just going to rewrite this formula here. The process otherwise is the same. So first let me talk about that process. We are going to take that probability, just like we did before. We're going to shrink down like Mike TV. We're going to go inside that Z table. We're going to come out of it with a Z-score of P. And then we're going to put it into this formula that we're about to cover. So what we want is to know the value of P. So we're going to take that Z-score for P, which is that right there, and we're going to multiply it by this crazy thing right here. So I'm just going to clean this up a little bit. We're going to multiply it by this. And then before we're done, we're going to add that. Now the formula, again, it's not the prettiest formula in the world, but it gets the job done. If we have a probability and we want to know what that corresponding sample proportion would be, given the proportion of the population, then we would shrink down, get inside that z-table, find a z-score, plug that in here, plug the proportion population, or the proportion of the population proportion. In other words, p-pop is what I call it. And we'd come on out. And just to be crystal clear, just as this square root covers this whole thing, this notation down here should cover the whole thing. Because it is indeed the same. Okay? And again, if this formula or this formula up here and quote intimidates you, or I would recommend that you set up Excel so that you can do those.